Alright, another draft physics video presentation. Draft science here on YouTube. Anyway, Veritasium video gets into all of this. Are photons really affected by forces? So is one of the forces, one of the things moving the speed of light, does it affect another force? And all the evidence is that forces really don't interact with forces, that you can't push magnetism, the force, into another force of magnetism and bend the force or any of that kind of stuff. You can't shoot two laser beams into each other and expect the photons to fly apart. Yeah, it just doesn't make much sense. Doesn't make any sense, frankly. So it's sort of an extraordinary claim to say that photons are material and they're moving the speed of light, that they're fundamentally different than the virtual photons of quantum mechanics, all of that stuff. And so it's just really poor evidence. And videos, I'm just saying, well, there's nothing I can say. People fell for religion and they'll fell for this stuff. And it's just as bad. It's, it's so thinly and weakly evidenced. And yes, it's the extraordinary explanation rather than the ordinary explanation. And this is apparently the problem with humans, is they're not very good at logic and reasoning and being fair to the facts, because they want the truth to be something else. I don't know why exactly they want it to be these stupid things, but apparently that's what you want. When I say you, I mean I'm talking to the general human condition, so nothing personal. Yeah, but you're all religious nuts, clearly. You just have different kinds of Jesuses. Little, bendy, warp space Jesus.
More about Salesforce at the end of the show.
Oh, I'm so excited. Just all the money being thrown at this crap. Shit.
The first piece of evidence that showed our universe is expanding came in the light from distant galaxies.
And let's understand the guy who found it, the evidence, right? The guy they name all this stuff up, Hubble, didn't believe any of this crap. So he didn't like where they took this. So it is, it's another way of irony. These poor dead people are just getting so ruined by these people. They have to have no respect for the dead. And they just keep saying that, oh yeah, they were all for this horse shit. No, they really weren't.
If you look at the spectrum of the sun, you see these dark lines. And we see those...
Yes, you look at the spectrum for any chemical, it has lines. It has places where the electrons say, yes, I will leave with this much. I will move this fast and no faster. You could argue. It's really just showing you the velocity of an electron. The frequency of the light is sort of based on how fast the electron moves from point A to point B, how fast it gets there. And that's sort of dictating what color the light will be. Because the electron's making the photon by moving in a field of force. Yes. Forces, or little force bits, are bouncing off the electron as it moves. So if it's moving towards you, it shoots a bunch of clump of them at you. And if it's moving away from you, it doesn't give you anything. No reflections. No light.
Same lines in the spectra from galaxies, except they're shifted to longer wavelengths, towards the red end of the spectrum.
So the photons are distant galaxies. The photons appear to be, stretched in the sense that they're changing from being the element of the photon is being stretched, you could say, if you think the photon is one singular thing. If you think the photon is made out of, say, 3 little bits, then you can understand the little bits are separating. Their frequency is increasing somehow. Their frequency is decreasing with distance. Now, the fact is that scatter causes this. So when a photon hits an atom, as it's transmitted through the atmosphere, for example, it loses, it's stretched a little through the transition of scattering off of an object. So it degrades its frequency in a general sense. That's the overall impact for billions of them. is a loss in their frequency. Now, the thing that ruins all of this whole conversation really can't take place, is the fact that they have converted frequency into momentum. So every time they say something changed its momentum, they say it has to be its frequency because it's moving at a constant speed. That's the only way they can say a photon has more energy, and it's just such a wrong way of looking at where the energy is. The energy is in the components that make up the photon. The energy isn't in the pattern of the photon.
So we say their light is redshifted.
Right. So the simple explanation is, is that there's a tiny amount, but there is a real amount of hydrogen, other kinds of atoms still floating around in space. And the fact is the further the light has to travel, the more likely it is to hit a few of those things. And it's been bounced around a little bit, been broken and remade and reconstructed through the process of being transmitted. Now, a lot of them are clear atoms, so the transmission isn't all that difficult, but it still counts as a scatter. It still counts as an event, and if they lose a little tiny bit of their frequency with each one of those encounters, you could understand why light from far away is redshifted. It would make perfect sense, and you don't need to believe it has anything to do with how the light was created by the object, and therefore it has nothing to do with any motion of the object. It just has to do with the fact that the light is essentially getting tired. Tired light does explain it. And you don't need to have an expanding universe then, and you don't have to answer all the paradoxical questions that expansion raises. Like, are we expanding? Is the atoms expanding? Is everything expanding? Because that expansion would require you to change the gravitational constant, and change the magnetic constant, and change the electrical constant, mu zero and epsilon, whatever the fuck it is.
Now, the usual explanation for this redshift is that as the light is traveling through expanding space...
So again, we have to accept the idea that space is just generating out of nowhere. We have this magical space. It's just filling between every single object. There's little tiny space pores. And the universe is leaking space juice through the space pores into the universe, like it was water. So if I give you a water example, it's like the ocean is sitting there, right? And there's new ocean, water molecules being created. Like at every single water molecule just all of a sudden doubles, right? That would be the fast version. And, so the ocean is just getting bigger and bigger and bigger, and therefore everything that was just sitting there minding its own business is getting further away from everything else because there's more ocean water between it, right? So two rocks could be sitting here and they're moving away from each other, but neither one of them has any velocity. They're just moving away from each other because there's more ocean water between them, right? So they don't have any velocity, so to speak. But even in that example, they would have to have velocity because they're being pushed away, right? Because if I made more water, you'd understand that that would be more water pressure, and it would push the rocks, and we'd see them deform and do all kinds of weird things because they're getting pushed by an actual pressure increase, right? They're not just passively saying, I'll just go wherever you tell me, right? Because we know the water, it doesn't work that way. So the water would actually have to push them, and so we'd see them crush and flatten and tear and do all kinds of things. But now if we assume that it's happening inside of the rocks too, that they're getting bigger, everything inside of them is expanding, whatever. I'm just saying it's just wrought with paradox.
Photons themselves become stretched. So shortwave...
So again, we go in typical bullshit drawing. They don't even draw it with the amplitude the same, so now they make it look like a tune, like a... Boo! Like it's a little musical tune. You're supposed to give it the same height to the lumps. It's very consistent that way. But anyway, it's this drawing that just ruins physics. This is just wrong, 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 wrong. It's just so depressing. It's so wrong, and I don't know why they've clung to this idiotic notion that there's this means something. What the hell does that mean? How did that ever mean anything to you? When they showed you, when I first saw that, okay, a physics teacher drew that crap on the board, my brain just said, "Oh, I'm in catechism or something. I'm in a religious class. This is what the hell is that Jesus particle? What the fuck are you talking about? What the hell is that? How does it know to do this squiggly crap, whatever this squiggly crap is? I mean, why do you buy this nonsense?"
Lengths get longer. This is known as
So, yes, it's known as the big story you tell. So you could, I could argue that if I make the photon, really a long ray of photon, where's the room for the expansion? If I expand the photon, what am I going to do with all the energy in it, that's spreading? I'm taking something that's, a certain size, and I'm obligating it to be a bigger size. Where's the space in the straight line for me to do that? Oh, yeah, that's right. There isn't any.
cosmological redshift. And the explanation is fairly intuitively satisfying in most.
No, it isn't. It's just totally unintuitively satisfying. I don't know how you get satisfied with this garbage they're feeding you. I don't know how any of you people eat this crap. It's like oysters or something. I don't know how you people eat shit like that. Yuck. Yeah, it doesn't have a brain, so okay. It's not much of a big worry on the ethical standards, but even if it was a vegetable, I wouldn't eat it.
People go on without giving it a second thought. But the problem is, if you do give it a second thought, you think, well...
Yeah, that's right. So if somebody actually thought about the garbage physics that you preach, and actually thought about all the paradoxes and all the nonsense and how it doesn't fit and how it's not consistent and how your bent space doesn't go with your quantum mechanics and all the rest of this crap, and you just throw it all out because it's all just garbage. You made it up out of nothing. I mean, the evidence is in shreds and in little tiny fairy dust.
If expanding space can stretch something like a photon, something that's so incredibly tiny, does it also stretch atoms and molecules?
I bet he's not going to answer the question. Yeah, because the answer would have to be, well, yeah, it would have to. Because it's one universe. I mean, the space filling between the electrons and protons is the same space that, up there, between us and the moon. Same space between the atoms is the same space between the moon and the earth. I mean, how can you say one kind of space is expanding, but no, the other kind isn't? No, it's all one space. It's all one ocean that all this stuff is swimming in. So how can you sit there and say part of the ocean is expanding? Oh, come on. It's a ludicrous pile of mush.
Molecules? Is expanding space stretching stars and galaxies?
Yes, it would have to. There's no rational way you could say it could work any other way. If there's space is poofing between them, how does the space know? Oh, I'm not supposed to poof, while I'm inside of a galaxy. And what's technically inside the galaxy is that little edge inside the galaxy. Can I poof there and make extra space? Oh, fuck.
And what about you? Are you expanding?
So he just keeps asking questions that he won't frickin' answer. I bet you. I haven't watched the video, but I'm sure he's not going to answer. I didn't watch to the answer end.
With the universe? To answer these questions, we've got to take a closer look at what it really means to redshift.
No, they were sort of yes and no questions. You don't have to look at nothing. You could just give me the frickin' answer.
Physicists actually talk about 3 different types of redshift.
Yeah, that's because they're all got all kinds of subcategories of raccoon, uniform they want to wear or something or whatever poofy-doo bullshit.
Doppler redshift, where observers moving relative to one another measure photons to have...
What a bizarre way to describe it, right? So, I mean, Doppler is being created because either the emitter is moving or the receiver is moving. So that's how you measure the shift, is just because obviously if I'm shooting a gun and I can actually move towards you really fast, you'd understand that the frequency at which the bullets are leaving are now going to be changed from your perspective because I'm moving closer to you when I shoot the second bullet. And I'm even closer to you when I shoot the third bullet. And likewise, if I'm moving away from you, the frequency of the bullets would be, stretched out, and there'd be much longer distance between them because I'm creating more distance between the bullets. That's Doppler.
Different wavelengths. Gravitational redshift, where observers at different locations in a gravitational field.
So this is just, totally made up. I mean, this is just something, well, Einstein said he thought, yeah, sure. I mean, if you could bend light around, suns, then sure, gravity must suppress light in some way. And so the suppression is going to be measured based on energy again, right? So they're going to measure its frequency based on how hot a piece of metal gets or some kind of other thing. It's not going to have anything to do with the truth. But anyway, let's play along.
Measure different wavelengths. And cosmological redshift, where observers exchange photons over vast...
Yeah, so this is not really happening. They're really not exchanging photons in the sense they're exchanging... this is the part where, you can understand it by saying, I can move something in directions like this, right? Now that doesn't mean that there's the things moving, okay, are moving, it's this whole component in this direction and a component in that direction. They're going away from each other because they're spreading, okay, in their velocity. So they have a velocity in this direction, but there's also a velocity in the sense between them. There's separation, the amount of time it takes, the amount of separation, and the separating speed, well, technically it can't be any worse than the 180-degree line, running away from each other. So that could appear like you're going twice the speed of light, but nothing's moving twice the speed of light, right? So if I have two things moving the speed of light and they're moving away from each other, their fact is it looks like that's a paradox, because nothing can move twice the speed of light. And from either one's perspective, they're moving twice the speed of light away from the other guy. But they're not. So that's sort of just fake. That's just has to do again with this perception crap. Doesn't have anything to do with what actually took place.
Cosmological distances in an expanding universe measure different wavelengths. These three cases appear very different, and they're governed by different equations.
Yeah, well, that's part of the problem too, is the equations are incomplete and silly. So, yeah, that's all you need to say about that, right?
So how does each redshift actually occur?
Well, whatever. Just getting into this, how does each redshift, well, okay. I mean, technically, look, the tired light is a kind of redshift. I guess I should draw it or something, but, and they, like I said, it's a known fact, so their own physics concedes that this happens, that when light scatters, it's slightly degraded in its frequency. So, I mean, it's already a fact they have. So why not pick the easy cause of the effect?
Let's start with a photon in a gravitational field. There is this famous experiment conducted in 1959 by Pound and Rebka, sending photons up and down a 22-meter tower at Harvard. Now, they used gamma rays, but I'll represent...
Yeah, something really hard, right? So, the whole idea that we have some perfect gamma ray detector, right? A thing that, the frequency is so small that, and this is 1959, I mean, the year I was born. I mean, that's how, we didn't even have watches. You didn't have to, reset every 15 hours back in 1959. So this is just a joke. Oh yeah, this experiment proves something. Oh, bullshit.
Them with visible light. They found that photons detected at the top of the tower were redshifted relative to the source by the exact amount predicted by general relativity.
Oh, it's always the exact amount. Isn't that convenient? Yeah, right. But it's just as bad as the Eddington experiment. Oh, it's the exact amount. Yeah. It's so far off that how would you know? How would you know?
Which is a tiny amount. I'm dramatically
Yeah, it's right. You're dramatically exaggerating it. You've cleaned up the experiment nicely. You know, you're not showing me 1959 pictures of this piece of crap. But whatever.
exaggerating the effect just so you can see it. Now, where along the photon's path does this redshift take place? Well, it seems to happen continuously.
Well, that would be the logical answer. He makes that sound like it's mysterious. Ooh, how's it where? Is a special place that it happens? No, the whole idea would be is that it's traveling through a fluid of gravity, and the gravity is little by little affecting it through its path. That would be the sensible answer. But does it really make any sense? Like if I had 3 bowling balls and I went up into space and then, and I dropped them towards the Earth, every bowling ball is going to be affected by the gravity the same way. So it's not likely that, if I drop them once a second, that it's going to change at all. Because there's not enough distance between the bowling balls for the, to spaghettify it. So, this is just silly. They're taking the smallest thing in the universe and say, look, I spaghettified it. So we can't see it with very long things, but we can see it with the various short things. So this is the whole LIGO bullshit. I mean, come on. Why do people fall for this?
The photon loses a little bit of energy each millimeter it climbs up that tower. Meaning...
Yes, now is the tower evacuated? I don't know the details of the experiment, but if it's not evacuated, then you're hitting a bunch of atoms and you're scattering the light. So we already have the explanation.
That the photon in the middle of the tower would appear green. Now, according to Einstein's equivalence principle, being at rest on Earth's surface...
I mean, part of the equation could be which way the little bits are being pressurized by gravity, right? So if they're being pushed down, like a few little atoms, like say, or whatever, that's real pressure, the force of gravity down on the molecules. And so that might be part of what causes the shift, is the direction of the molecules you're flying into.
Is indistinguishable from being in a rocket.
All right, so we're back to this indistinguishable part. And as I pointed out, the only thing that's the point you should realize is that the force of gravity, you will never feel it, because it always moves all of you the same. So you can't feel it because it doesn't change something. It doesn't bend your fingers or do something. When it affects you all the same way. And it's all the other forces, every single one of the other forces, that doesn't evenly affect you. That does push one part of you more than another part. Like any force I apply to myself will deform me and cause irregular changes. And especially a rocket ship, for example, leaving a gravitational field. I'm not feeling the gravity at all. But I'm going to feel the rocket because it's going to push my feet first, and it's going to push my bones, and it's going to leave my stomach behind, and it's going to very unevenly accelerate me, where the gravity always accelerates you evenly. That's the only difference. Ugh. Shit.
In deep space, accelerating up at 1g. So
the only force you're going to feel is the force of the floor pushing you up, because the gravity, you can't feel it, because all of its pushing will be so even.
We could do the same experiment in a rocket ship, and we should get the same result.
Well, this another part of this. Why bother doing it that way? Why don't you do it in some real circumstance? So now he's saying that motion itself will cause this redshift. And no, what motion does is cause the emitter. If you're moving, the emitter's moving. This is the Doppler redshift you're going to create, because the emitter keeps changing where it is. Okay, we'll go to the drawing board. That should work. Well, that is irritating. So I have to get rid of this to do that. Oh, well, that's annoying. All right, I can do that though, because it's not that inconvenient. All right. So, So now we're just back to this, what do you think these things are? I mean, do you really think that, okay, here's a surface that's going to produce light, and in one instantaneous moment, the surface just goes, bloop, photon. Do you really think that happens? So even if the photon, okay, is 3 miles long, because it's a radio photon, even if it's 3 miles long, there's no photon, the photon is in here as some form of energy, and in an instant, and instantaneously, okay, just instantaneously, bloop, 4 miles. You think that's what happens? Come on, you people aren't this stupid. All right, so obviously the surface has to create the photon. And it's telling you so overtly by having a frequency, it's telling you I'm made of pieces. That's what having a frequency just, unlike their stupid, silly, where they go, well, every time there's an on-off pattern, it's interference. No. This one you can sort of rely on, that anytime you hear about a frequency, it means something's got pieces to it. Okay? One thing just can't do that frequency thing. So the obvious thing is that this is a timed event, an event that happens, and it takes time for it to happen, and the frequency is telling you exactly how much time it takes. So the photon basically is being emitted in sections. Okay, the front end of the photon pops out. All right, so we can draw it as a wave if it makes you happy. I could make that so much bigger, but anyway. And so there's the front end of the photon. Now we know if this thing's moving very fast, right? It's moving very fast. We're accelerating, okay, in this direction. We're accelerating the emitter. Well, then you can figure out that this little bit, this wave, it's going the speed of light when it leaves. It's, it's on its way, but we're going to send more of it in just a little tiny, a trillisecond later, we're going to send another piece. So this thing gets a certain distance. But the fact is that this thing moved, okay, in that time too. So the emitter's now a little bit closer to it, right? So we know that this next wave is going to be kind of encroaching on the other wave a little bit, that, it has to in a sense, because I haven't allowed the proper distance between the continuous shape, so that I've sort of, I guess I don't know how to draw. It may be easy for me to draw it in the right physics, right? I should just do right physics and just say to you people, just get with the program. But anyway, the point would be is that you could understand if I shot the photon and we understood the photon was elements, quanta of momentum, okay, then you could understand that the next cannonball, okay, the next bullet is going to be a little bit closer than it would have been if I had this stationary. So if this thing was stationary and it wasn't moving this way, then these two balls would be, this would be the distance. And because it's moving, the distance is going to be this, right? So I'm going to have less distance between the bullets, all right? That's the simple explanation. And obviously the opposite is going to happen on the receiving end. The receiving end is going to say, it's moving away from the cannonballs as they're coming in the bullets. So now the distance between them is going to seem longer because, you keep moving away. You catch one, and then you're running away, and then you're going to catch the next one. Well, now the frequency between them has to be longer because you're running away. And so that's the Doppler redshift. Put that back here and put this over here. I'd like to be able to pause, but I just can't, so.
If we send blue photons from the back of the rocket, they should be red when they reach the front. And in the middle of the ship, they would appear green.
Alright, so when they reach the front again, so he's totally ignored the fact that the receiver's moving away and the emitter is moving towards, which means there would be no difference. So if both of us are throwing ball back and forth, right, I move forward, you can understand, okay, I've compressed the frequency. If I move away, you can see I've stretched the frequency. But you can also understand both of them are moving. There's not going to be any difference. There's not going to be it's red at the bottom and it turns green at the top or whatever. None of that's going to happen.
This is exactly what we saw at rest in a gravitational field, so the equivalence principle holds.
Yeah, he says he through, childish animation.
Now imagine there are a line of external
So this is where I stopped watching, just because this is so stupid.
observers just hanging out in space at rest relative to...
So we're back to this stupid, idiotic crap of, it's all about your perception. So it's all about what you believe. It doesn't have anything to do with reality. There's not a reality to describe. Let's just talk about what we see. Bullshit.
each other, and they can all see into the rocket. Let's also say the rocket is initially at rest, and the thrusters are switched on the instant the photon is released. Now, since both observers are at rest at this moment, they will both measure the photon as having the exact same wavelength. It's blue.
All right. So the observers are, what are they looking at? Okay, because we can't see the photons, right? So the observer can't see a photon unless you make the photon go to the observer. We can't see photons passively. We have to see photons basically take the path. So obviously both observers are seeing photons that never go anywhere. I mean, they stopped going where they were going because they went inside their eyeball so they could see them. So this is all part of the fraud of this.
What about when the photon reaches the middle of the rocket? Well, we know someone inside will see it as green.
Right, so somebody outside is going to see it as exactly the same color, because just think about how they're going to see it, right? So let's say the frequency has changed, and now the photon hits a piece of dust. It's a laser beam, and there's a piece of dust, and now the photon bounces into his eye and he sees a green photon. Well, if the same thing's going to happen to this observer out here, he's going to see exactly the same thing. He's going to see a green photon.
But what about a stationary observer outside? Well,
see, so he's pretending that somehow the observer can see the elements of the photon, and that there's some reason why the observer is going to say it's some other color, and there really isn't any reason to. If I turned them into little bullets moving through space, all right, and I put 3 little bullets, and I said, okay, now the bullets are a little bit further apart, they're green, okay, they have the green distance, all right, there's no reason why the outside observer would see it any other way. He'd see exactly the same distance. It's like saying the outside observer thinks the spaceship is 600 feet long when it's only 60 feet long. There's no reason to think he'd see it any different.
for them, the photon has just been moving through ordinary flat space-time, so it must look blue.
Right, so you couldn't do this with any other analogy. If it was a flying bird, if it was any other thing, this crap of a diagram wouldn't work. There wouldn't be no way for you to believe what he's saying you're going to see, because you wouldn't see it. So if I made it a flock of ducks coming out of the bottom of the spaceship, and the flock of ducks have a certain distance between them here, right in the middle, we assume that the flock of ducks is changing their distance. Both observers are going to see exactly the same thing. So this is just garbage.
It's as blue as it was when it was emitted.
So this is just absolutely no good reason to believe that would happen. So no matter what, like I said, you can't even think of anything I could possibly make this photon out of if I made it into any other elemental thing besides just his simple animation. And I showed you 3 little things left here, and the 3 little things are separating as they travel. So that's we're giving you the premise. We're saying, yes, they're getting further apart as they travel. There's no reason for this guy and this guy not to agree on what they're seeing.
So what's the deal? How can the same photon look green and blue at the same time?
It can't. So your whole premise is nonsense. I mean, I don't know why you're even attempting this silly argument, because it's just silly. You can't see photons change color. You have to actually see the photon by having its frequency go into your eye, and there's no reason for this green frequency to scatter towards you, to be deflected towards you, and you say it's blue. There's no reason, no explanation, no logic, nothing. It's junk as a theory.
Has the equivalence principle been violated? The answer is...
the equivalence principle been violated. So apparently they've turned it into this equivalence law. And again, it's just so ignorant not to recognize that gravity is fooling you, because gravity isn't a feelable force. You'll never feel gravity push you anywhere, ever, because it does it so evenly. And that's it. But it's just as real a force as the earth pushing you back. The only one you feel is the earth pushing you back. You never feel gravity. Oh, God, this is frickin'...
No. It matters a lot to this measurement who is doing the observation.
No, it doesn't. The universe is doing one thing, newsflash. There's one universe, 3 dimensions in the universe. We're all in the same stinking space, and we're all in the same stinking time. If it's 10 o'clock on your watch here, guess what? It's 10 o'clock at the end of the universe. It's the same time everywhere. It's all happening now, and it doesn't happen any other time than now. And that's it. The future hasn't happened yet, and the past is long unrecoverable. And you people are just silly.
Consider this. After the photon is emitted, the rocket accelerates. It's speeding up. So by the time the photon reaches the middle of the rocket, everyone inside is now moving at high velocity relative to the source when the light was emitted.
And the source is moving. So again, you can't get past the fact that, see, they just think all this stuff just poofs into space. It's just the instantaneous poof. I instantaneously poofed a 4 mile radio wave. No, you didn't just instantaneously poof it. I mean, that's their theory. Doesn't understand. That's how their math works. Their math thinks that one moment there was no 4 mile long radio wave, and in one instant, poof, there it is, 4 miles. It just showed up at the 4 mile point. It didn't have to travel there somehow. Yeah, it did. And the same thing's happening throughout the whole process of when an emitter's moving and when a receiver is moving. It's catching and throwing differently.
And relative to the observers outside the rocket. So it makes sense that the photon as measured inside will look different. It'll be redshifted. This is the Doppler redshift, because...
So again, just a silly explanation. It happened right there at the source. It didn't happen in space. So the redshift that happens, the Doppler redshift, happens at the source. And the same redshift will travel through any amount of space. So if a train is coming towards you, and the sound is changed, it doesn't matter how far away you are, the sound will be the same. It doesn't get more and more shifted with distance. So this is just nonsense. This gravitational redshift shifts constantly. If it existed, it would shift constantly. And so would the redshift of space, tired space theory, or the idea that space still has enough crap in it to slow photons down a little bit. Not slow them down, but you want to interfere with their progress a little bit. Yeah, that would be happening continuously. So the further away the object is, the more redshifted it would be, because there's more likelihood it went through more crap that slowed it down, that shifted it.
The observer in the middle of the ship is moving very quickly away from the source. By the time the photon makes it to the top of the rocket, well, the rocket will be going even faster, and this is why it appears red.
So there's no appears anything. This is just such bad physics.
But to a stationary observer outside, well, it still looks blue.
Wrong, wrong, wrong. You can't look anything, and it is what it is. You either accurately see it or you inaccurately see it, but that's it. There's only choices. You either put a distorted piece of glass in the way of your vision or you don't.
This thought experiment shows us that wavelength and energy are not intrinsic properties of photons.
Wavelength and energy are not intrinsic properties of photons. I don't even know how you can get away with that statement. Clearly, frequency is intrinsic. All right, and no, but what do you mean? Unmutable? Is that what he meant? Unmutable properties? Yes, you can change the frequency of a photon. But its energy, that is the energy of the components, you can't change that. That's the quantum part. That's the Planck part.
They are properties of the photon observer system.
Oh, whatever. So, forget it. Too silly.
Now, let's recreate the Harvard Tower experiment. Observers in the building see the photon redshifted as it climbs.
So the real sensible argument to you is, as you know, it either is or isn't. It's in its condition. Let's just describe its condition. Let's not talk about what silly observers see. Let's just talk about what it actually is. And why is it actually that? How did it actually happen to it? That would be the questions to answer. But they'll come nowhere close to answering these questions. So again, let's go back to his original question. Is everything in the universe expanding with the universe? That is, are helium atoms getting bigger and bigger? And are gold atoms getting bigger and bigger? Is everything getting bigger and bigger because of the expanding space? Answer that question.
But here's a question for you. What would a free-falling observer see? Well, they would be just like...
So we're just back to this silly notion that, again, the free-falling observer is being aggressively pushed by gravity. Yes, he doesn't feel it because it's not hitting him like a floor. Okay, gravity's not a floor that hits you and pushes your head faster and crushes your head into your feet. Okay, gravity doesn't do that. Gravity hits everything. It's pushing his feet just as hard as it's pushing the rest of him and his arms and all the rest of this. All the little atoms are being pushed equally. So he doesn't feel anything. It doesn't mean he's in any free state at all. There's a floor aggressively smushing him towards the earth. That's the fact. That the actual fact of gravity is there is a floor on his head pushing him into the ground. And he just can't feel it because it does it so well.
The stationary observers in space watching the rocket accelerate up. The physics of these two situations are identical. So,
and it's identically silly. It has nothing to do with observation. It has to do with you're physically arguing for something. You're saying that as the photon transitions through this distance, that the force of gravity, the force that's pushing this guy into the earth, that's aggressively pushing, all right, is somehow going to aggressively push on the little photon as well. That's your argument. So show evidence supporting the argument, not this theoretical mush about what an observer sees.
they would measure no redshift. To them, the photon would look blue the whole time.
All right, again. So this is just so illogical. It's in a state. The photon is in a state. It either is or isn't. You can't sit there and say it would look. Who cares? I mean, frankly. But there's no way it could look that way to somebody going the opposite direction of the photon. That would really be silly.
What I want to show is that there aren't actually three different types of redshifts. There is only one. We've seen that the gravitational redshift...
So, yes, I would argue there has to be two. All right. We know that the redshift being caused by the transition, whatever you want to call it, scatter causes redshift. It's a fact. And clearly that could be caused because you're changing, because the atom that the photon is going to interact with and be caused to scatter or to go transition through, because it's a clear molecule, that has in it moving surfaces. And so it's moving surfaces, emitters and receivers, that revolves emission and reception. That the atom receives the photon, and the atom is also going to emit the photon at the other end. So we can have moving emitters and receivers involved. But you can't say for sure that's what's causing the effect. So, I just say it's not all the same. I think that's just a bold statement based on very little evidence.
It can equivalently be seen as a Doppler redshift when we do the same analysis in an accelerating rocket ship. So what about cosmological redshift? Well, for this, we have to zoom way out, past our solar system, the Milky Way galaxy.
Yeah, so again, this is just nonsense, right? So this is this balloon argument. I put a bunch of dots on a balloon, then I blow up the balloon, and the dots get equally distant from each other. They move away from each other. Now, on the balloon surface, right, because I'm blowing up a balloon, the dots are physically moving, okay? They actually have velocity. But you got to sort of understand that if you're doing this expanding space thing, it's not like you really are pushing the dots, right? You're just displacing them in space because you created more space. So they didn't really have momentum because you didn't apply a real force to push them away from each other. You just created more magical distance between them, right? I mean, you just injected more distance, but the objects themselves never got pushed by a force. So you really can't understand it as being their momentum. They don't have momentum. They don't have actual velocity because you just displace them in their position in space by injecting space. This is such a pile of crap. I just don't know why people would believe this. I can't even believe I have to have a conversation about magically making space. Oh yeah, we're making empty space. Everywhere except inside of objects.
Our local cluster of galaxies, we want to zoom so far out that the galaxies in the observable universe are like molecules in a fluid, the cosmic fluid. At this scale, we can treat the whole universe as being smooth and uniform. Cosmologists say it is homogeneous.
So what's the point of this, right? I mean, they're so disconnected from actually arguing the facts and the truth. Let's just pretend, the world is a piece of, the moon is made out of cheese. This is moon cheese theory.
And just as you don't notice the individual molecules in a cup of water, at this scale, we don't notice the individual galaxies in the cosmic fluid. And the cosmic fluid looks the same in every direction. There is no preferred orientation. It's said to be isotropic. Now, what you'll notice is that the cosmic fluid is spreading out. It doesn't matter where you look, you see the same thing. Things moving up.
I'd rather not be looking inside the fluid. Let me see. You said we zoomed out. I want to see the universe ball thing. Okay, so I guess you didn't zoom out far enough because you're still stuck in the milk. I want to see the milk bottle. Then you can talk to me about this expanding space bullshit. I want to see the bottle get bigger and bigger.
Part. The density of the cosmic fluid is decreasing over time. And this is the basic property of an expanding universe.
Oh, so it's not really expanding, it's that the little bits are getting smaller. So of course there's more distance between them because they're getting smaller, so everything looks longer. See? I mean, if you're 6 feet tall, then 3 miles looks really this far. But if you're only 3 feet tall, then 3 miles looks like it's 6 miles. It's just shorter.
We can draw some coordinates on the universe. We could pick any different coordinate system we like, but one way it's often done is to make a coordinate system that expands with the cosmic fluid. So there will be certain observers whose coordinates don't change over time, and these are known as co-moving observers. They are at rest with respect to the cosmic fluid. By the way, on
so they're moving in the same direction as the expansion. That's what he's really saying. They're moving in the same direction. The expansion is going this way, and they just happen to be going this way. So the ones that won't be, are the ones going some other way than the direction of the expansion. So that's all they're saying. So yes, some pieces will look like they're moving, and some pieces won't look like they're moving. Ooh.
Earth, we are not a co-moving observer. Our galaxy is moving at 600 kilometers per second relative to the cosmic microwave background radiation. Now, let's pick...
So there's no proof of that, frankly. We don't have any... you can't see our direction based on the cosmic background radiation. That's just silly. It looks even from every direction. It looks like we're not moving. So I don't know how he uses that. I don't know how he uses cosmic background radiation to deduce our velocity. That's just too silly.
Two co-moving observers a large distance apart and have them exchange a photon. Its wavelength will be stretched by the amount the universe has expanded during the photon's journey.
Yes, that'll be true of every single photon released into any space ever, anywhere. The same exact thing is going to happen. So what?
Standard picture of cosmological redshift. But now consider a bunch of other co-moving observers along the path of this photon. Each one absorbs the photon and instantaneously emits another, identical to the one they measured. Now each successive observer will measure a slightly longer wavelength.
So again, he's talking as if they can do this passive measuring thing, but this is sort of a good illustration of the fact that, well, what if photons actually did hit atoms in space, and what if it was true, that's been proven true, that photons' frequencies stretch with scatter, that scattering photons increases their frequency, makes their frequencies larger, makes their wavelength larger. Well, then that would certainly explain why all the stuff that's far away is redshifted, wouldn't it? Yeah, it would. Simple explanation. Don't need all this wooey expanding space horseshit.
Than the observer before them, the photons stretching out just as you'd expect in an expanding universe. But the reason they would give for this redshift would be different. To each observer, their neighboring co-moving observers would appear to be moving away from them in locally flat spacetime. So they would attribute the increase in wavelength to the Doppler shift, just due to the relative motion between them. The entirety of the cosmological redshift...
You can't even make sense out of that. I mean, did you understand what you just said? There's no way you can understand what you just said. I mean, this whole idea that there, these people in space they're measuring a photon that's traveling by them, you could say, and they're doing this looking thing again. So have the light scatter into them, a laser beam, and some tiny portion of the laser beam shows you what the photon looks like. That would have been a much better analogy, but this, how can you make any sense? They're moving toward and away from each other, so they're creating Doppler shift while you're explaining cosmological shift.
Then can equivalently be thought of as the result of a long series of Doppler shifts. What we've seen is redshifting is not something that happens to a photon itself. Instead, it depends on what's happening to observe.
Okay, so isn't this just too silly? It doesn't happen to the photon itself. So the sound wave isn't crushed by the train. It's not actually had its frequency actually changed where the molecules are in a different position closer to each other. The densities of atoms aren't actually physically closer to each other. It's some sort of perception bullshit. No, it's not a perception bullshit. They're crushed. When the plane's going the speed of sound, it's crushing, the atoms. None of them can go anywhere. The sound can't move because the plane is going as fast as the sound is going. That's a physical fact. And if you're going to use these analogies, then you ought to be at least consistent. The photon doesn't change. What a pile of crap.
Observers at the point of emission and absorption of that photon. And because of this, there are actually not three different types of redshift. There's only one, described by a single underlying mathematical framework.
No, that's just, so again, as I point out, it's obvious nonsense. The clear redshift that takes place, again, the scatter redshift, you can't say is the same thing. You have to show how it's the same, where the moving surfaces are.
They only look different depending on your frame of reference. Now, it can be convenient to talk about expanding space when you have two co-moving observers exchanging a photon over vast distances.
So does this feel like he's going to answer the question of are atoms getting bigger? Do you think he's going to answer that question?
In an expanding universe, then the photon's wavelength is just stretched by the amount the universe expanded during its journey. That's nice and simple. But you can equally well describe the redshift by a long chain of Doppler shifts, no expanding space required.
Yeah, but you could do that without all of this crap and just say there's little tiny bits here in the space. The space isn't as vacuum. It's not. There's no perfect vacuum, and without that perfect vacuum, and especially when you think about it, the old universe would be a lot dirtier, presumably. Although, if it's true that the galaxies have expanded, that the quasars are really galaxies, and that through the evolution of time the galaxies are falling apart, if that were true, then yes, there'd be more noise in the current world than there was in the past.
The misconception is to think that because photons are redshifted as they travel across the universe.
So let's just say again, that doesn't mean anything. They're redshifted by stretching. So he's using a metaphor that's just too biased. All you know is that you have this change in frequency, and then you're trying to figure out why. Why do the photons appear to change their frequency with distance? And I would argue it's the extraordinary explanation to say space is expanding, and that one of the ordinary explanations, merely involving the fact that the photon is interacting with something that's causing the effect, is the right answer.
That means expanding space is pulling on things and stretching things apart. That's not how it works. Space is not like that. So he's saying it doesn't really happen. He's saying it's all perceptual. The photon never changed. Isn't that essentially what he's saying here? He's saying there's no real effect, and somehow we're just making it up. When our telescope sees the light the wrong way, telescope's just being a retarded perceiver. I mean, come on, this is just stupid. Back to the central question.
Yes, go back to the question. Now you can answer all the questions no, because it's all an illusion. It didn't really happen. Space isn't really expanding. Just looks like it is.
Of this video, which is, do you expand with the universe? The answer is no.
So it's silly and stupid, right? I mean, it's an extraordinary statement. Okay, so the rest of the empty space is expanding, but the empty space inside my atoms, no, it's just staying exactly the way it was. I mean, too silly.
Because on the scale of people, the universe is not homogeneous. I mean, matter is condensed down into objects and the Earth. And
no, there's still space inside the matter. So you're just pretending matter is solid. When there's space, there's more space than there is matter in an atom. So you can't sit there and just use this homogeneous argument. It's not homogeneous. Atoms aren't homogeneous. Proton, electron, quarks, you have all these, you think there's 400 little different kind of weird little stuff flying around in the non-homogeneousness. How can you sit there and say it's homogeneous? Bullshit.
And the universe is not isotropic. Looking up looks decidedly different from looking down. The basic assumptions we made about our expanding universe just don't apply here.
Right, because that would be insanely inconvenient, because now you'd have to change all of the constants and you'd have to say, wow, this whole thing is really complicated.
I mean, the local space-time curvature is dominated by the Earth.
Ugh, pathetic. So what would the curvature have to do with the fact that space is multiplying? So it's multiplying perfectly evenly out there, but it's not multiplying at all in here. I mean, come on.
So what if we took you out into deep space, the middle of nowhere? Then
what if we shrunk you to a tiny, tiny, tiny little person, and you were just as big as an electron, and you were sitting there outside of an atom, and you knew, there's electrons over there, and there's a proton nucleus over there, and there's another atom over there, and some guy told you, oh, you're not really in space. Yeah, no, that's not space. Space is outside the atom. You're inside an atom. No, it's not space. Sorry, you're out of luck. Can't exist because there's no space inside the atom.
Would you expand? Still no, because your body is held together by electromagnetic forces. But what if we could turn...
So again, the universe is held together by gravity, and you're violating it to push it apart. You're expanding the universe in complete violation of gravity. So why can't we violate charge? And charge is so much stronger a force, yes, but still. You have to account for the space creator. How are you going to just pretend it can't create space? There's too much pressure or something? What's your argument going to be? Why it can't create space inside of objects?
off the electromagnetic force, so your body is just a jumble of particles that don't interact.
So that makes no sense either, which we know they do interact, so that doesn't even make any sense.
Well, in that case, over time, you would expand. But only because our universe is now dominated by dark energy. So
oh, please. So the rules don't apply. The big objects do something, the little objects don't. Different set of rules again. So, I mean, just bullshit.
Take-home message of this video is that redshifting photons don't mean that space is expanding. And
oh, yeah, that would be really great if that was the take-home message. I mean, I should just cut out that little clip, okay? Because redshift doesn't mean expansion. Yes, that's true, it doesn't. You really haven't proven that argument. Expansion is a silly explanation.
And pulling on everything, stretching things apart. So molecules are not expanding, and neither are stars, and neither are galaxies. And
okay, so again, so nothing's expanding. Does this make any sense? I blew up the balloon, the little dots went further away, but they didn't really go further away. Isn't that what he's saying? I mean, could this be any more convoluted? And people lick this shit up. Oh yeah, give me some more of this bullshit. I mean, absolute bullshit. I mean, yes, Jesus, rose from the dead and made a contract with the Holy Ghost. I mean, this is such a religion.
Neither are you, except for very extraordinary circumstances.
God damn.
That tells you it's recording.
Oh, jeez. He's going to do a little kid thing. Send me some more money. Get me richer and richer for talking shit. Fucking baboons.
Here we go. Hey, this portion of the video was sponsored by Salesforce.
Oh, by some kind of racket that I get paid to talk about how great the frickin' racket is. I don't even want to know. Do I want to know what Salesforce is? Is that anything I would ever go near? It has a cloud around it, so ooh, yeah, ooh, it's a cloudy thing, right? So it's technological cloud stuff.
A company that can help you expand your business.
Oh yes, isn't that just so charming? I just love the businessmen. Ooh, they're just so great. They buy stuff, buy low, sell high to the American sucker consumer. Let's see how much I can rip them off. See how much, graft I can pull out of every single human exchange. Oh, I just love the businessman. And the little shills for it. Oh, God, yeah, he really is dislikable now. I mean, he was just a benign tumor before, but yeah, now I can really hate him. Because now he's just shilling for shit. Ugh. God. Yuck. Screw your customers even more efficiently and reap more profit. Fucking goddamn people. What ugly fucking furniture. What the hell is that? Yeah, it's ugly. Frickin' grade school globe. It's got a seam in it. You can buy them without seams now. Anyway. No, okay, it's enough of the video. Yeah. Oh, I just hate this planet. I hate it. I hate it. I hate it. I wish there were more giant meteors ready to strike. I wish I could live to see the day. Yeah. Because you're really bugs. You're so frickin' belligerently stupid. Yeah, it's just nothing to say. Yeah. Alright, so till the next time and such. I guess I should say that without putting that in the way. Let's do this properly. So this has been a Draft Science video presentation. Thank you for your participation. And till the next time and such. Yeah, I do hate you though.